Hello everyone, myself Sowndarya. I am guided by Dr. Venkatesan. My doctoral research topic is on real-time reconstruction of two-phase flow regimes using optical sensor. The current research focuses on analyzing two-phase flow regimes which is flowing inside a mini channel made of borosil. Two-phase flow is nothing but a simultaneous flow of two different phases in same conduit. The current work primarily focusing on identification and reconstruction of slug and bubble regimes in real time. This is done by processing the electrical signal which is acquired from the optical sensor with the help of NIC DAC. Here, the laser diode is used as the transmitter and the photoresistor is used as the corresponding receiver. MATLAB code is developed with the steps which I have shown here. Initially, it is made to acquire the data, then it will identify the critical time instance of the current signal. This both slug and bubble regimes exhibit a V-shaped, W-shaped and YW-shaped pattern. These are the three different pattern of this signal. Critical instance pointed for the YW shaped pattern is shown here. This plot is obtained by simulating the slug regime in COMSOL multiphysics software. This is achieved by replicating the optical sensor characteristics in simulation software. Therefore, this graph is plotted between photons falling on the receiving wall and position of the slug regime. 8 critical instances are shown in this figure. This instance can be similarly seen in experimental graph 2, which is plotted between the current versus time. This will provide information about the slug like the time at which the slug's nose, body and tail enters and exits the laser trajectory. Once these instances are identified in experimental signal, then type of the regime like whether it is slug regime or bubble regime can be identified. Once the regime is identified, next step is to calculate the regime's velocity. If it is the slug regime, its axial dimension can be calculated from this critical time instance. Then experimental current value is converted into the photons. Prior to the signal processing, a numerical simulation is already done to relate the liquid film thickness and the photons. Similarly, an empirical relation is obtained to find the bubbles dimension. For slug regime, by stacking the calculated liquid film thickness corresponds to every time instance, and by knowing the axial dimension, three-dimensional image can be reconstructed. Similarly, bubble regime can be reconstructed, but both regimes are made to position at the center of the here is the reconstructed image of the slug and bubble regimes which I have kept at the center of the mini channel, and this is the shallow information about my whole doctoral research. First of all, I thank SASTRA University for giving an opportunity to pursue my doctoral research, and I thank my guide for his support and belief on me. Finally, I thank everyone who watched this video.